Oh, fourth grade, can you believe that you're on your second page of table of contents? My next two pages are 39 and 40, and today's called Module 3, No Lesson, Module 3, Multiplication Strategies Review. Starting our new lesson in Eureka Math, we're going to be reviewing the 3 strategies we've learned so far. So take a moment to put in your title, and then let's get going. Our objective is that we can multiply using area models, partial products, and the standard algorithm strategies. So let's start with our area model, which is the strategy that we learned first. 3 ways we're going to be multiplying the sentence 2,642 times 5. For our area model, we have to break down our number in the thousands by expanding it. Remember, expanded form is when we pull out our ones, tens, hundreds, and thousands. And we multiply it all by the number 5. So on this side of our area model, since it's all the same consistent height, we're going to label this 5. But 5 isn't just the height of this part of our area model. It's also the height of this line, and this line, and this line. Now let's expand 2,642. I actually prefer to start with my ones and work my way up the place values. So I'm going to expand this number into 2 ones, 4 tens, which equals 40, 6 hundreds, which is 600, 2 thousands, 2,000. Now I know the width of each section of my area model. I know the width, I know the height, and I can use these 2 numbers to multiply together to find the area of each piece of our area model. First, we're going to multiply 2,000 times 5. Then we'll multiply 600 times 5. Can you guess the multiplication sentence for our tens? 40 times 5. And finally, let's multiply our ones. 2 times 5. Remember, when we multiply by zeros, we start with the math fact, and however many zeros are in our multiplication sentence is how many zeros go into our product. 2 times 5 equals 10. I have 1, 2, 3 zeros in my sentence, so I'm going to tack on 1, 2, 3 zeros. 10,000. I'm going to plug 10,000 into my addition sentence for all my partial products. Let's move up to our next highest partial product. 6 times 5 equals 30. I have 2 zeros. That'll add to the end of 30. 1, 2, 3, we. Our next partial product is 3,000. To make sure it's all lined up, I'm going to line my comma up first. There we go. And now my partial products are lined up nice and straight. 4 times 5 is 20. With 1 0 at the end, 200. And last but certainly not least, 2 times 5 equals 10. Adding up all my zeros in my ones place. 110, 2 hundreds, 3 thousands, 1 10,000 for a total of 13,210. Before I write my answer up in this line, let's make sure we're absolutely correct by trying out the same problem with our partial products method. Remember, partial products is a lot like our area model. We're just doing the multiplication without the visual of these boxes. Let's start with our ones. 2 times 5 is 10. Now I'm moving into my tens place value. And 4 represents 4 tens. In fact, I'm going to put a placeholder 0 here. 4 times 5 equals 20 for 200. And I notice my partial products are lining up consistently. 10, 10, 200, 200. Let's see if the next partial product we get is going to be 3,000. This is 5 times 600. In fact, I'm going to put 2 zeros in my partial product as placeholders. And now I'm going to solve for 6 times 5. 6 times 5 equals 30. 1, 2, 3, whee! 3,000, 3,000, we're lining up nicely. Let's do this again in the 10,000s place. When we multiply, in the thousands place. When we multiply in the thousands, I have 1, 2, 3 zeros as a placeholder. 2 times 5 is 10. Just like in this partial product. And when I add up my partial products again, I'm still going to get the same answer, 13,210. Let's go down to our standard algorithm and practice it. 2 times 5 is 10. I'm going to leave behind my 0 ones and regroup my 1. 4 times 5 equals 20. And 20 plus 1 is 21. I'm leaving behind the 1, 1 and regrouping the 2. 6 times 5 is 30. 30 plus 2 is 32. So far, we're lining up real nice. Let's see if this happens in our thousands place as well. 2 times 5 is 10. 10 plus 3 equals 13. 1, 2, 3, whee! We have the same answer 3 times, which means that we're accurate. Let's write our final answer in the line up above now that we know it's absolutely true, 13,210. Now I'm going to give you an extra step here. Which one of these is your favorite strategy to use? Is it the area model, partial products, or standard algorithm? And I'm going to have you draw a smiley face next to the one that you prefer to do. For me, it's standard algorithm, but you might feel differently. So take a moment to draw a smiley face next to your favorite strategy. One more time, let's practice the same multiplication sentence 3 different ways, with an area model, partial products, and a standard algorithm. 3,407 times 6. We're going to expand 3,407, and we're going to multiply it by the same number, 6. I'm going to label all of the heights of my area model as 6. And I'm going to expand 3,407 into 7 ones, 0 tens, which just is 0, 4 hundreds, and 3 thousands. For each of these boxes, now I can find what multiplication sentence to write because it's how tall the box is times how wide the box is. That's why we call it the area model. You're finding the area of each of the boxes. 3,000 times 6, 400 times 6, 0 times 6, and 7 times 6. Let's start with our largest number. 3 times 6 equals 18. 1, 2, 3 zeros. 1, 2, 3 zeros. 1, 2, 3. 18,000. 4 times 6 is 24. 2 zeros, 2 zeros. 1, 2, 3. I'm going to line up my comma first to make sure my place values are all lined up. Then I'm going to write the rest of the number, 2,400. 0 times 6, well, anything times 0 is just going to be 0. 7 times 6 equals 42, and I'll plug that in to the end of my partial products. I have 2 1s, 4 10s, 4 hundreds, bring down my comma, 10 thousands, and 2 10,000s. Before we get too confident and write our answer up in this line, let's check our work with partial products and the standard algorithm. Remember that we had the same partial products with our area model and this method in the last problem, and let's see if that happens again. 7 times 6 is 42. 0 tens times 6. Well, first I'm going to put my placeholder 0 because I moved on to the next place value. 0 times 6 is, well, that's 0. So I'll just put in another 0. Now let's do 6 times 4 hundreds. The hundreds place has 2 zeros in it, so I'm going to use 2 zeros as a placeholder. 4 times 6 equals 24. 1, 2, 3. Whee! Now we're going to multiply 6 times 3 thousands. I have 1, 2, 3 zeros. Now let's multiply 6 times 3. 6 times 3 is 18. 1, 2, 3. Whee! All right, let's see if we get the same answer. 2 1s, 4 10s, 4 hundreds. So far, so good. 10 thousands, 2 10,000s, 20,442. But again, before you get too confident and start writing your answer here, let's solve it one more way using the standard algorithm. 7 times 6 is 42. We're going to regroup the 4 10s. 0 times 6 is 0. 0 plus 4 is 4. I have nothing to regroup in the next place value. 4 times 6 is 24. I'll leave behind my 4 1s, regroup my 2 10s. 3 times 6 is 18, and 18 plus 2 more equals 20. I have no more place values to regroup to, so I'm going to put the number 20 down below. 1, 2, 3, whee! And one more time, draw a smiley face next to the strategy that you like the most, because maybe you've switched since practicing them a little bit more. Maybe you like partial products a little bit more, or standard algorithm. That's completely up to you. But now it's your turn to practice these 3 strategies in your problem set today.